As mentioned in the email this video is attached to, a valuable antique chest is to be moved into a truck. The weight of the chest is 1,400 newtons. To get the chest from the ground onto the truck bed, which is 1 meter higher, the movers must decide what to do. Should they lift it straight up, or should they push it up their 4 meter long ramp? Assume they push the chest on a wheeled dolly, which is a simplified model, is equivalent to sliding it up a frictionless ramp. There's 4 parts to this question, with part A reading, find the work done by the movers on the chest if they lift it straight up 1 meter at constant speed. Part B is find the work done by the movers on the chest if they slide the chest up 4 meters long frictionless ramp at constant speed by pushing parallel to the ramp. Part C is find the work done by gravity on the chest in each case. And part D is find the work done by the normal force on the ramp of the chest. Assume that all the forces are constant. Well, in order to calculate work, we must calculate the force exerted by the movers. So I drew the force body diagram to help me calculate the forces and account for all of them. So the ramp is a simple machine, and this means that it can't reduce the amount of work that must be done. So before this problem, I kind of expected that the work done by the movers is going to be the same no matter which way they do it in both cases. So we expect the work done by gravity to be negative in both cases, since the chest is moving up while gravity pulls down. And the normal force due to the ramp is perpendicular to the displacement. So it does zero work on the chest because forces that are perpendicular don't do work. Since more than one force does work on the chest, I used subscripts like F prime to clarify which work is being calculated. The first thing I did was draw my knowns of what I do know, and that is that the weight of the chest, mg, is going to be equal to 1,400 newtons. The length of the ramp is d is equal to 4.0 meters, and the height of the ramp is equal to h is equal to 1.0 meters. And what I'm left to find is the work done by the movers on the chest, which is going to be labeled as W sub m, and work done by gravity on the chest, which is labeled as W sub g in both cases. And then the work done by the normal force on the chest, which is going to be W sub n. Now the displacement is 1 meter straight up, so the movers must exert an upward force equal in magnitude to the weight of the chest to move it at constant speed. So the work done to lift it is going to be equal to this equation here, which is going to be W sub m is equal to F sub m change in R cosine of theta, which is equal to 1,400 newtons times 1 meter times cosine of 0, and that is equal to 1,400. Now, this is where theta is equal to 0 because the force vector sub m and the change in R are in the same direction. They're both in the same upward direction. So then we move on to part B, which I showed the sketch of the situation again. So I was able to take the x-axis along the inclined ramp and the y-axis perpendicular to the ramp and resolve the gravitational force into its x and y components. And then I drew the force body diagram to show the forces acting on it, with F sub m going up and mg going down. And this is when it's sliding along at a constant speed. The chest acceleration has to be 0, so the x components of the forces add to 0. Now the x component of the gravitational force acts in the negative x direction, and the force exerted by the movers, which again is F prime sub m, acts in the positive x direction. So from here I use this equation of the sum of the forces in the x direction is equal to F prime sub m minus mg sine theta is equal to 0. And then from the right triangle formed by the truck from the ramp to the ground, I was able to get this equation here, which is sine theta is equal to the height of the height of the truck bed divided by the distance along the ramp, which is broken down simpler into h divided by d. And now that I have this formula, I'm able to solve for the F prime sub n, which is going to be this equation here, to where it is equal to mg sine theta is equal to mgh divided by d. And this is the force and the displacement are in the same direction, so theta is equal to 0 again. And I was able to get this equation here, which is W sub m is equal to F prime m times d times cosine of 0 is equal to mgh divided by d. times D times 1 is equal to mgh, which is equal to positive 1400 joules. So just as we expected at the start of this problem, the work done by the movers is the same as in part A. Now in both cases, moving on to C, the force of gravity has the magnitude mg and it acts downward. Now I chose the y-axis so that it now points upward to give us FGY is equal to negative mg. And in both cases, the component of the displacement along the y-axis is the change in y is equal to h, which is equal to 1.0 meters. So the work done by gravity is the same for the two cases. And then I was able to use the formula here, which is W sub g is equal to F sub gy times the change in y is equal to negative mg times change in y. And after plugging my values in, I get this out to be negative 1400 joules. And now I can move on to part D. And to do this, the normal force of the ramp on the chest does no work because it acts in a direction perpendicular to the displacement of the chest. So I get this formula here, which is W sub n is equal to n times the change in r times cosine of 90 degrees, which gives us, again, our work of 0.